In this lab, we are emphasizing accuracy and precision. Accuracy is how close is a measurement to a true value, and it answers the question, were you close to what you expected to see? Precision is how small is the range of measured values, aka how good were you at collecting the data you wanted to collect. This graphic indicates a target that has different types of accuracy and precision. So the most accurate target shooting is the one on the top left corner. So we see that all of the marks are near the bullseye, which means that the shooting was very accurate. It's also very precise because all of the marks are close to each other. If we look at the graphic to the right of that, it is inaccurate but precise. So all of the marks are close to each other, but they're not close to the bullseye. If we go to the bottom two graphics, we see that they're both imprecise. So the one on the left is accurate because you're close to the bullseye, but all of the markings are far apart from each other. In the bottom right, you see that none of the markings are very close to the bullseye, and all of them are far away from each other. So this is a great depiction of how we can differentiate accuracy and precision, and we know that good data is both accurate and precise. There are three different types of errors that can pop up when you're making measurements. Illegitimate error is error that is mistakes in your measurement or your computation. So these are mistakes that don't really count as error because they can be corrected just by repeating a measurement. Then there's systematic error. Systematic error are mistakes caused by human or instrument error that cannot be removed by repeating the experiment. So the way you would correct systematic error is by recalibrating an instrument and then taking new measurements. There's also random error, which results in errors in observations that vary from experiment to experiment. So in each experiment you would have different errors. The way you would correct these errors is by taking multiple measurements or using a better instrument. We can use percent error as a relative measure of how good our data are. Percent error is defined as the absolute value of true minus measured over the true value times 100%. So for example, we can see what is the percent error where the density of copper was experimentally determined to be 8.4 grams per milliliter, and we know the true density is 8.96 grams per milliliter. So we calculate percent error as 8.96 minus 8.4 divided by 8.96 times 100%, we get 6.3%. So that's a fairly reasonable error based on the method of measurement.